Hello, everyone. Today I'm going to be talking about a paper slash study done by Middle et al., talking about antlers in red deer and senescence and also genetic variation. So, as a broad picture, we know that senescence affects most traits, but not all. And we know that senescence has to deal with aging, which causes a decline in, most traits like fertility or having to do with survival. But what these researchers found is that in this specific place in the the Isle of Rum in Scotland, these species of deer, their antlers weren't aging and they weren't affected by senescence. And so they wanted to explore this study and basically ask themselves, why does this secondary sexual trait is resistant to aging? So the study that they did happened over a 50-year period. Once again, this happened on the Isle of Rum in Scotland. During these 50 years, they had about 1,700 male deer, and they tracked them for size, their antler sizes, their genetics, and they also tracked their breeding success. And what they did with all of these deer is that they split them up into three separate categories for which they called age classes. So the first class was the young deer, which were aged between 3 to 7 years, the prime deer, which were aged from 8 to 11 years, and then the older deer, that's from 12 years and beyond. And the reason that they did this is because they wanted to see basically how genetic variants changed within each class and also how selection changed within each class as well. And then what they did is that they compared the data that they took between each classes. So they would compare young and old, prime and old, young and prime, et cetera, et cetera. And so the key findings of this study was that it is true that antlers resist aging, but a really important fact about this is that, as you can see, there's two things. For the breeding success within these red deer, it's in the prime age range where there's a peak in breeding success, and then you see it'll increase from young, peak from prime, and then it will start to decline in old, showing senescence. However, though, when you look at the graph on the right under form B or under figure B, you'll see that antler form will start to increase in variance, but then it will plateau even in the older ages. It does not go back down after. And so we're seeing this genetic variance increase and selection is weakening as the deer are getting older, but the antler shape and the antler size is not decreasing even in the older ages. And this suggests that there's some type of genetic link that are keeping the ages across the antlers, and they're keeping the antlers large even across all of these all groups. And so when you're thinking about this genetic constraint that's helping evolution keep the antler form size, you're thinking, why is that important? Well, what it means for evolution, why it's important, why it's helpful, anything like that, is that if antlers are genetically constrained, they can stay large even in old age. And yes, even though we're seeing that reproductive success is declining, the genes for large antlers are still remaining active and they're still staying. And so this is a very important insight because it shows how a secondary sexual trait like this one can resist to aging. It also shows how that even within different species or even within like one species, that the traits they don't age the same. There are some traits that, like we would expect, do decline and do senesce as um the species get older, but in a rare case like this, there are some traits that will be able to stay. And so, in short, the time goes on and it does dull many traits, but evolution is keeping red deer antlers sharp. And what this means is that it's important to look for traits that still have some type of genetic benefit And it explains why, even as time ages, the species will still have these traits shown. So I hope you enjoyed my paper, and I encourage you guys to check it out.